Hello everyone. So in previous session we'll discuss about what we cover in further classes and I'll discuss about the whole topics what we are covering in these PD classes. So from tomorrow today onwards we are starting our actual classes. So today I'm start the topic regarding to introduction of VLSI. Okay, let me share my screen. Is it visible, right? 1 minute. Okay. So today we are discussing about introduction to VLSI class. So in previous class also I'll discuss about this thing. What is VLSI? What is the full form of VLSI and all? So VLSI is the process of creating an integrated circuit. How? By combining million or billions of transistors on a single chip, right? Sorry, let me draw. So assume this one as a chip and we are placing transistors like this on a chip in such a manner. So we are placing millions or billions of transistors like this on a single chip. This whole process is known as VLSI, right? Are you agree with this point? Okay. And after that, sorry, we are having some scales. So in these are the types of integration, how we are scaling integrated circuits and all. So these are the types. First one is SSI, MSI, LSI, VLSI, and ULSI. If you guys know what is the full form of all these things, let me comment down in the comment section. Stop the video and comment down and continue the video. If some guys don't know the full forms, don't panic. I'll let you know. Okay. So first one is SSI. SSI means small scale integration, right? So in previous years, in olden days, in 1960s, so we are placing transistors. So is it same chip. So in this chip itself, we are placing transistors. So up to the limit of only 100. So we are placing only 100 transistors only. If you are having 200 transistors, we cannot place 200 transistors on a single chip by using SSI, small scale integration. So if you want to place 200 transistors, we have to choose two chips, right, to place this 200 transistor. So this is the drawback of this one. So we are moved to medium scale integration, MSI. So in that one also, in MSI also, we can place only up to 1000 transistors only, right? So up beyond 1000 we cannot place all these transistors. So we move forward to LSI, large scale integration. In large scale integration, we can place up to this count of transistors. So after that, we are moving to VLSI, very large scale integration. So in this chip itself, we are placing billions of transistors, right? So we are placing billions of transistors on a single chip by following some guidelines and all. Okay. So after that, we are having ULSI also, ultra large scale integration. But up to now, we are stuck at VLSI because this one is sufficient for us nowadays. So if in future itself, if you want to place more transistors beyond this VLSI limit, so when that things comes to picture, then we will use ULSI also. But present, we are using VLSI. This one is sufficient for us. Okay. And after that, 1 minute, guys. Okay. So why? What is the importance of VLSI? So these are the main things. First one is performance. As performance wise and cost reduction and power efficiency. All these things are the important considerations in VLSI. first one is performance. So if you are having more transistors, uh, 1 minute. So in this shape, we are having more complexity. So if you're having more transistors means there is a chance of more complexity, right? But if you're having more transistors means we can work on it more. So we have more memory, we have more advantages in some users also. So if you're having more transistors, our performance will be more, right? So we have to choose more transistors, and as less complex wise we have to place the transistors, okay, then the performance also good, okay. After that, cost reduction. If you are having mass producing complex systems on a single chip, okay, so if you are having 200 of transistors, okay, and I want to place all these 200 transistors on a single chip, right? Consider this one as a case one. So I'm placing 200 transistors on a single chip, okay, like this wise. So I am placing all these 200 transistors on a single chip. This is the first case, okay, and consider second case. So in this one also I'm considering 200 transistors, but in this case I'm taking two chips. So in these two chips I'm dividing these transistors and I'm placing transistors in 100 transistors in this chip, and the remaining 100 transistors on this chip, okay. So in this process we are considering two chips, right? So at this case the cost also increases. You guys are know about silicon chips are very expensive, right? So in this process cost also increases, so we have to manage to place more transistors on a single chip. So at that time your cost also reduces compared to SSI. We are using nowadays VLSI, right? So in that case we are reducing the cost also, right? And this is the thing. And after that, power efficiency. So miniaturization means small things or portable things. If you're having less size and also power consumption also reduces, right? So if you are having more huge hardware, so at that case we have to give more power, right? Compared to small size hardware. If you're having more hardware, big size of hardware, then power also increases. So at that case also in VLSI we are using small kind of chips. So at that time power also reduces. After that, coming to Moore's law. So, as you guys familiar about what is meant by Moore's law, so VLSI is mainly depends upon this Moore's law. So, Moore's law means the number of transistors count to placing on a chip. So, number of count of transistors on a chip is doubled for every 2 years, right? Note this point. What is meant by Moore's law? Number of transistors on a chip is doubled for every 2 years. Okay. So after that, so what are the careers in VLSI? So these are the different fields. So first one is RTL design. So these are some fields, only some roles only. We are having more roles also. So I'm here. I noted only four or five things. So first one is RTL design engineer. So what is meant by RTL? Register, transfer, level, or logic, right? So let me draw. So consider one AND gate, AND gate, and AND gate having two inputs. One input is A, another input B, and output is by. So what is this? AND gate. Okay. So what is the logic of AND gate? What is the truth table? This is the output. What is the truth table when we are having 0, 0, 0, 1, 1, 0, and 1, 1. So 0, 0 means 0. So when both the inputs are high, then only our output will be high, right? So we are RTL people define this logical connectivity in coding wise. Those people write the code to this logic by using some HDL, VHDL, and Verilog formats. Those people are write these codes for this logic. After that, verification engineers are going to be uh, correct these codes if any errors are there. They are verifies the logic, and after that they forward to physical design people. So physical design people are going to be do if you're having a chip like this, they they are using by using this logic, they are converting this RTL logic. They are this they convert this RTL logic into a physical layout. Okay, na? Physical, understand, guys? Sorry. So, physical design engineers are going to be convert this RTL logic into a physical layout. They are placing all these transistors on a chip, all these logics on a chip. So actual physical layout plan and all is de defined by physical design engineers. After that, CAD engineers. So CAD engineers role is to develop the software tools like consider EDA tools. So if you want to write the RTL code, or if you want to verify that code, or if you want to design this physical, what is the work done by all these people. So there should be work on some tools, right? Some EDA tools like synopsis tools, EDA tools, or cadence tools. All these tools are designed by CAD engineers. So they are creating those softwares, and they are verifying those software how it will works, and the roles are coming under CAD engineers. So after that, analog mixed signal engineers. So this guy's role is to design non-digital parts like interfaces, PLLs, and ADCs or DACs. Like, so if you want to give clock to my block, so consider this one as my block. So in my block having some connectivities and all, some logic is there in my block. So I want to give clock to my block. So I want to give clock to my block. So this is the source point. Source point is my PLL. PLL means, if you guys know the what is the full form of PLL, comment down, stop the video, comment down. Okay, and continue the video also. So PLL means phase local loop. Okay, so what is the purpose of this phase local loop is generating clock signals. Okay, so before that itself, it works to produce the clock signals, right? So all these things and all these logics are prepared by analog mixed signal engineer guys, and ADC, DACs, analog to digital converters, or DACs, digital to analog converters. All these non-digital parts are created by analog mixed signal people. Okay, and after that, 1 minute. So if you want to do all these things and all, we have one chip, right? One IC. So in that IC also we are going to do all these things and all. So before that we have to know how this chip is fabricated, how wafer is prepared from sand. You guys all know about silicon is extracted from sand, right? So how this process is explained in small steps. Actually, this is the very big process. If if I have time, I'll explain these things also in further classes. So silicon is actually extracted from sand. So first process is the we are taking sand, and to extract sand, some process is also there. So we are extracting silicon from sand. So after that, when silicon ingot is prepared, so this is how it looks like. This is how it looks like. So it is in cylindrical, similar to cylindrical shape, right? So sorry guys. So all let us assume this one is a cylindrical shape. So that cylindrical ingot is cutting into small pieces again. Okay, circular pieces. So this is the side view. If you want to see the top view, then it looks like this, right? This is the almost looks like cylindrical shape, right? So if you want to, we are cutting this ingot, silicon ingot like this. This is the side view, and top view is this one. So each one is wafer sliced from ingot and polished. So this one is the, what is this one? Wafer. So we are extracted this from ingot, right? So after that, processed wafer, this one. So if you observe these things, this wafer is divided into such blocks, right? So here each one is called as die. Okay, each one is known as die. Die is looks like this, right? So sorry. So this is how a die looks like. So in this die itself, we are started working like from the process of system specifications to how we are generating, how we are fabricated a chip. So we are works on this die. So this is the process how a silicon is extracted from sand to how a fabricated chip is prepared. This is the actually this is very big process. So I'm here explain in very small thing. So if I have time, I'll explain that process also. And after that, hmm, mass transistors cross section. What is mean by MOS? Metal oxide semiconductor, right? So here, before going to physical design classes, you guys should know about how mass is worked. So in we are we are mainly working on CMOS transistors, right? What is mean by CMOS? What is the full form of CMOS? Metal oxide, complementary metal oxide semiconductor, right? So this is the MOS transistor. So this is which type? N, P, N, right? So observe here. So here electrons in source cannot flow to the drain because P type region is barrier. Observe this one. So here whole the thing is P type, right? So when electrons are flows from source to drain, they cannot flow from source to drain because here P type is works as a barrier. There is no flow of source to drain. There is no flow of electrons from source to drain, right? If you observe this thing, You can find out that one. So there is no path in between source to drain. So there is no flow of electrons. There is no flow of electrons means the transistor is in off state, right? So observe this one here. We are we are not giving any kind of voltage, right? So at this we are giving, at this stage we are having 0 volts at the gate. So there is no path is there in between source and drain. There is no flow of electrons. So this transistor is in off state. Okay. And after that, this one. So compare this both these things. So here, here we are having some path, right? How this path is created. So before that we are having, at gate we are having only 0 volts, but here in but here we are applying some volts. Okay, so by applying this voltage, so all these electrons are, 1 minute. Okay, sorry, this one is not visible. Okay, so when we are applying voltage at the gate, then all the electrons attracts towards gate in this manner. Okay, so at this stage there is a formation of channel, right? There is a formation of channel here. You observe this channel, right? So there is a path from source to drain. So there is a flow of electrons from source to drain. At this stage, see, now electrons have a continuous path from source to drain, right? There is a, here channel is created when we are applying voltage at the gate, right? So at this stage, channel is created. So there is a flow of electrons from source to drain. So there is a flow of current also, right? So at this stage, transistor is in on state. Okay. Are you guys agree with this point? So, so this is here we now we are combining both the things. So this one is the NMOS and this one is the PMOS, right? So here I am considering both NPN and PNP. So this one is NMOS and this one is PMOS. Here source, here source, drain and channel are in N type, right? This one, sorry. So observe this one, and after formation of channel also, after applying some voltage here, again attraction of electrons towards this one, and here channel is channel is created. So at that stage, channel also in N type, right? So after that, this one is PMOS. Here source, drain, and channel are in P type, right? So then it will be we named as NMOS and PMOS, right? P type of MOS and N type of MOS. So here we are combining both NMOS and PMOS. So at that time, when for one thing is in off state and then another thing in on, sorry, one thing in on state and then another thing in off state. So these are complementary to each other. Let me draw. This one is P-type and this one is N-type, right? Here VDD and this one is ground, right? So here we are having gate. So here we are applying some input at the gate, right? So let's consider 1 minute. Okay. So if you are giving 0 as the input to the gate, so when we are giving 0 at that stage, what? PMOS will be on, right? And NMOS is in off state, correct? And when you are giving 1 as the input, then PMOS is in off state, NMOS is in on state, right? So we cannot on both at the same time in CMOS, right? They are complemented to each other. Both NMOS and PMOS are complemented to each other, right? That's why we named it as complementary MOS. Correct? Are you guys agree with this point? So then no current flow because one device is always off. Correct? So consider in first case one device in off, in second case another device in off. Correct? So at this stage we are saving the power also. So the main exception is, what is the main exception of this CMOS? Current flows only when devices are switching. When it is switching from 0 to 1 or 1 to 0, then only current is flows, right? When the devices start switching, then only our current is flows. So this is called as complementary CMOS. This is the quick review of, this is the basic level of CMOS logic and all. So after these things, these are the today's questions. List the major steps involved in VLSI design flow. If you guys know the flow of VLSI, right, from system system specifications to how a chip is fabricated and all, so it follows some flow, right? VLSI design has some flow. Let me comment down in the comment section, or else let me know in the Telegram channel also. This is the first question. And what is the difference between front end and back end in VLSI? We are having two designs, right? One is some people are works on front end and some people are works on back end, right? So what is meant by, what is the difference between front end and back end, and what are the roles and what are the work are done by front end and back end people? Let me know in the comment section or else in the Telegram channel. So take these two questions as homework. Okay. So that's it for today's class. Thank you guys. If you guys are having any doubts and all, comment down. I'll reply accordingly. Thank you. Have a great day.